So let's get into it. So my name's Sanjeet. I'm an infrastructure security architect at Cisco. Wore a couple of different hats over the years, but primarily my role is looking at Cisco's internal IT infrastructure, driving security end-to-end. Focus has primarily been on network security. And so that will be the lens that we look at this session today. So over the past year or so, year and a half, been part of a big project to uplift a lot of our on-prem network and security stack to the cloud with Cisco Secure Access. So over the next hour or so, we'll have a look at what that journey looked like, and then we'll touch on Zero Trust. What does that actually mean? How does that facilitate the journey that we've been on? And how we've implemented that at Cisco ourselves. So maybe some quick housekeeping. There's a WebEx app. I will try and answer as many questions as I can. We've got 60 minutes. I'll try and get through all the content. I'll be available for questions at the end. But if for some reason I can't answer your question or can't get to it in time, just put it in the WebEx app and I'll get to it eventually. So brief look at the agenda just to set the stage. We're just going to start with looking at Cisco IT. What does our overall landscape look like? And then sort of go into some of the business problems that we've had to deal with. Hopefully, if you're in IT organizations yourselves, you can maybe relate to some of the challenges that we've been through, some of the stuff that we're trying to solve. Once we kind of set that stage, we'll go into how we started to solve some of those challenges, primarily with remote access, so looking at VPN as a service with Cisco Secure Access. We'll then look further into Duo and how that's helped augment our Zero Trust goals. So we'll primarily be looking at the Duo Network Gateway and how that sort of helped provide borderless access to applications and sort of dialed up security quite a bit for both remote and on-prem access. And then we'll look at Zero Trust access within Cisco Secure Access specifically. So there is a ZTA component in SSE. How is that similar to Duo and VPN, and how is that different? We'll get through all that, and we'll go quite technical into how that actually works and what's the business value that's actually provided to us, right? Because we all love playing with technology, but at the end of the day, we've got a business to run, and IT is a fundamental enabler for the business. So all of this cool stuff that we play with has to provide benefit and enable those business goals. And then we'll end on some practical guidance. So some of the stuff that we learned across the journey, and hopefully it'll be applicable to you. So just a quick snapshot at Cisco. I'm not going to go through all of these numbers, but the main message here is we have a large and diverse landscape of 85,000 users, full-time employees, but that goes up to around 130,000 contractors and employees. So each of these are in different business functions. So there's really a diverse set of use cases that we have to solve for. We have to connect them to the applications and resources that they need to do their jobs, not only in a performance way, but also security. Apply security end-to-end across that connection flow. So quite a lot of devices, both endpoints, collaboration devices, routers and switches. We deal with quite a lot of network traffic. So there's so many broad use cases that we have to solve, and it's difficult to maintain security and user experience as we enable the business. So a bit of a snapshot into specifically the security challenge we have at Cisco. So, we have security layered throughout our network. We have quite a large SIEM, security incidents and events management tool. We use Splunk, and that's processing around 8 trillion events per day, which is quite a lot, right? On top of that, we have 50 billion net flows analyzed per day. So we use StealthWatch, now called Cisco Secure Network Analytics, and that's sort of keeping a broad spectrum of visibility into what's going on, who's talking to what, and how, for how long, all the metadata around those connections, because we want to be able to dig into that when we're looking for threats inside our network. 47 terabytes of internet traffic inspected, so across our global locations, so we'll go into that in a little bit with what our backbone looks like. But there's quite a lot of traffic that we have to inspect, both going to on-prem data centers, But now these days, more and more of that is going to internet, the cloud, SaaS apps, that sort of things. So we have to make sure we maintain visibility across all those connections. Lots of DNS. DNS is quite a critical control point for us. With the rising use of encryption across the enterprise, DNS, remains a fundamental control. We have to look at all the malicious domains that threat actors are spinning up and make sure we have protection against all of those. Email is actually, still quite a big threat vector. We analyze a lot of emails coming through each day. And probably in the last year or two, maybe even more than that, there's been quite a rise in attempts at business email compromise. Can anyone guess why that would be? AI, exactly, yeah. It is becoming so much easier for threat actors who may not even speak the language to write a perfectly formatted email that looks exactly like something legitimate that you may see. So they're utilizing that quite a lot. So it still remains a critical control for us. And then also intrusion alerts. So we have IPS, IDS in our environment, doing inspection for a lot of those network flows. That's still alerting for a lot of events that we see happening. So across the spectrum, you can see there's quite a large number of data and information that we have to stay on top of. And this, again, can be quite difficult to do because you want to look at this data with context of what's actually happening. And as I mentioned before about all the diverse use cases we have, that can be quite challenging. So for an IT organization, it's quite a balance of priorities for us. So we want to enable business transformation. We want to ensure the user experience. But on top of that, we have to keep the network up and running day to day. So there's a lot of infrastructure operations that go on, right? And these, at least for us, these are kind of the three core things that as an IT organization, we try to deliver. But whilst we're doing that, we're constantly being asked to lower costs and also maintain security across that spectrum. And this can kind of be hard to balance. Does this resonate with anyone? Kind of going through these things, see some heads nodding. That's good, yeah. So it's tough, right? Every time you want to implement something new or enable a new business use case, InfoSec comes in and go, no, you can't do that. You have to be secure. Or it's too expensive. We have to lower costs. We have to find a better way to do that. So it can be quite difficult to maintain this balance. So that's the challenge we have ahead of us. So how do we solve it? Well, I'd be remiss if I said we've completely solved that today. It's always going to be a challenge, but this is how we attempted to solve it. So there's something that we internally branded in Cisco IT called CloudPort. That was essentially a on-prem, hardware-based network and security stack. So routers, switches integrated with firewalls, IDS, IPS, a bunch of security appliances, proxies, etc. We put those in co-location facilities worldwide. The reason that we did that is probably over the last 10, 15 years, we've noticed a trend of the explosion of cloud, right? So traditionally, most of our traffic went to on-prem data centers where we hosted our private applications. Now that is a broad spectrum of split across on-prem data centers, partner networks, SaaS applications, infrastructure as a service as well, living across AWS, GCP, and Azure. So across Cisco, we have to manage access to all those different environments. So colos made a lot of sense to us because we could peer directly with a lot of those cloud providers where we noticed the majority of our traffic flows had shifted towards. So we participate in IXP. We do direct peering with Amazon, Google, Microsoft, Salesforce. I think we have around 200 to 300 IXP peers per location. So that's the reason why we did that, but we wanted to make sure, as we make those connections, you need to secure them as well. So all the things that you see on your left, when I talk about diverse use cases, that's kind of what it looks like. We have to connect all those things to what we see on the right-hand side here. And that can be tough to do. So That was our attempt at it. Probably started this around 10 years ago, and then of course COVID hit, so the explosion of remote work made that even more difficult to do because it wasn't just applications that are moving across on-prem and off-prem. We also had users that were working from home, working from coffee shops, sometimes traveling to the office, and they all expected the same experience, no matter how they connected. But it is quite a significant challenge for us to maintain this infrastructure stack. It took quite a large engineering team, not only to build and design it, but also to maintain it. Because we're dealing with hardware boxes here. We have to manage P-certs, getting things upgraded in time, making sure we have link connectivity, making sure all our peering stays up. So there's quite a lot of time invested in just operating the platform rather than enabling those new business services that we want to do. So that's kind of the reasoning we started looking at a cloud delivered model, and Cisco Secure Access seemed like a great use case for that, where we can offload a lot of those functions that we run on-prem to a cloud-based model where we kind of just consume it as a service. So we're no longer running the underlying infrastructure that applies all these policies. We just define the policies ourselves, and it's up to the cloud to instantiate that across the different set of use cases that we have. So a quick look at our backbone. So I mentioned this before. It is a bit hard to see. I apologize for those people in the back. But you can see we have a global presence. We're in all the major cities. And if you look at some of the dots here, you can see at the legend up here, those are where the Amazon, Google, and Microsoft data centers are. So when I say we put ourselves in strategic colos, they're literally co-located near those data centers, again, because we noticed most of our network traffic was going through one of those locations. So that's kind of how we stitched up our network, and then we have private WAN backbone connectivity that interconnects all those sites. So it's kind of a snapshot of what we have today. Now, if we talk about how to apply zero trust across this architecture, it's quite a big question, right? Zero trust has been around probably for quite a while now. I'm hoping people here are familiar with that, because that's going to be the bulk of this presentation. Does anyone want to have a go at defining what zero trust is? It's hard, isn't it? I think from a few of the laughs, we all know there's not one answer to this. Some people might think it's a specific policy you put in place. Some people might think it's a specific architecture or a solution or a technology. It can be all of those things, maybe even more. But I'm going to have a stab at that. This is our perspective. So zero trust, view that as more of a philosophy or a mindset of really that least privilege access. So in terms of the principles that IT tries to stick by, we really want that consistent user experience no matter where they sit. So I talked about the diversity of use cases where users sitting at home, at the office, at the campus, or at a coffee shop, wherever. We want to make sure that for them, nothing changes in terms of the user experience. They can still work as usual, but make sure that's secured in the same way. Should be independent of the underlying network. So again, doesn't matter which location that should be. The security policies that we apply should be consistent regardless of where they sit. And then really having that continuous validation of identity and trust. So we know, about the perimeter model. It's no longer enough. Just establishing connectivity and authenticating once, that's not enough, because threat actors these days is not so much as about exploiting vulnerabilities from the outside. Most of the attacks that we see is just abusing valid user credentials. So they may, steal some credentials, they get off the dark web, and then, they're on your network. No exploitation or scripts necessary, just get some valid credentials. So the way we combat this is making sure we continually validate that you are who you say you are, and that the device that you're on is trusted, because that initial root of trust, of authentication, is no longer enough. The other thing is, I'm going to primarily focus on users and devices today, but there are things also. We have IoT devices that connect into the network, and we want to apply similar principles to those. So we really want to have that continuous verification of their identity, The way we get that identity may be slightly different to users, but we should be able to apply, in principle, the same sort of security policies. And then that last line, I think that really, at least in our opinion, encapsulates what we want to drive towards, which is that least privilege access, only allow access to exactly what you need to do your job, and micro-segmentation, which sort of goes hand in hand with that, right? So we want to segment things, not break connectivity, so you really got to have a good understanding of this business roles in your organization, what they're trying to talk to, what's a valid business use case, and make sure we only allow those trusted connections and nothing else. So, yeah, so for me, it's really that least privilege access with that continuous verification, and that gets us closer to that nirvana state of having a zero trust architecture. So that's setting the stage. How do we get there? So I'm going to jump into what we did with VPN. So that was kind of the default network access method, right? So obviously we had people coming into the office, but then with COVID coming around, most of our users were sitting from home and they were connecting through VPN. So we really want to make sure, since that was the primary method of connectivity, and that is also probably one of the most dangerous because you're exposing your VPN concentrators to the internet where anyone could connect, we really want to make sure that authentication is secured. So that's where we started this journey. So in terms of what we actually did, we took it as a refresh opportunity. So one of the things in IT, we call ourselves customer zero. So we deploy Cisco products and solutions in close partnerships with the BUs, but we're not just a glorified lab for them. We're doing this in our production networks with real users, with real SLAs who need to be able to do their jobs. So we want to make sure this stuff is road tested before it comes out to you guys. But also conversely, that means that we're not going to just automatically deploy this at scale. We kind of need a phased approach to make sure that we ourselves in IT have confidence in the solution before we open it up to the entire workforce. So the migration journey looked a bit like this. We did have a use case where we had some end-of-life VPN hardware. So the choice was either spend money, OpEx and CapEx, to refresh that hardware, or start looking at secure access where we can get rid of that hardware and just consume it from the cloud. In terms of the actual phases that we broke up into implementing that, is basically just making a new VPN profile available to users in their Cisco Secure Client. That's what it's called now, yes. AnyConnect within Cisco Secure Client. So the first option was, we didn't want to completely cut them over. Could be fairly risky. We still hadn't built full confidence in the product and solution, so we gave users the option. They just had it in their dropdown, and if they found it, they'd be able to connect. Next phase was give them a little bit of more of a nudge, so make SSE the default. So not just make it an option, but when they open their AnyConnect, it is the one that's pre-selected for them, and then they can just click connect. And then the third phase was, a bit more of an aggressive nudge, which is take away the options for on-prem completely, make SSE the only option, so they have to connect to that. And throughout those phases, we did some analysis, we did some both data analysis, but also some user experience surveys to sort of gauge our success at each phase and making sure we're ready to move on to the next one. And that really gave us confidence to then start moving towards the workforce. And then when we got to the workforce, kind of a similar approach. So, making SSE an option in your VPN dropdown, then making it the default, and then taking away your on-prem options, and you can only connect to SSE. So what that actually looked like, is this. So on the left is what we had before. We had a bunch of options because we had VPN concentrators all around the world, and we gave users the choice to connect to each location. Engineers loved that. Most of the workforce didn't really care, and it got confusing sometimes. They're like, why have I got such a big list? Which one should I connect to? What will give me the best performance? So really simplified that with secure access, which kind of runs on an Anycast model. So We do have a global presence with secure access, but when you click, you only get one of these two options, and they will automatically latch you on to your nearest VPN concentrator. So from a user perspective, you shouldn't have to worry about that. You just click connect, and you're ready to go. So we talked about rolling VPN out, and then I briefly mentioned the authentication experience. And if we bring it back to zero trust, we want to make sure we have strong authentication, and then that continuous validation of identity and trust. So how does a user get connected to the VPN? There's some pre-steps. First thing is they need to be checked in to MDM. So in IT, we use Intune and Jamf. We also use Fleet we have a small presence for Linux endpoints. But that device should be continually checking in. And then we have a synchronization between that MDM and Cisco ISE. So Cisco ISE has a database of which devices are currently managed by MDM. And then we can start to leverage that for the authentication flow. So first thing is certificate-based authentication. So we run enterprise CAs. We load a certificate onto the endpoint. Again, our MDM helps with that deployment. And then you authenticate directly to the head end via that certificate. So no longer having to type in your username and password. Your device, if it has the certificate, that's some assumption of trust, and we can use that to connect you straight away. But then we have that posture check. So not only should your device have that certificate, it needs to be within posture. What does within posture mean? Well, in this case for VPN, it just needs to mean that it's connected to the MDM and it's currently managed. So the VPN head end will punt that request to ISE and go, hey, this is the unique identifier I got for that device. Is it currently managed by MDM? And then if it is, we permit network access. This is how we gate remote access into our network. Getting into the traffic flow. So this is a bit detailed, but I'm going to step through it quickly because we talked about the authentication and authorization pieces before. We do some split tunneling. So ZTNA, which we'll get to in a bit, I want to split that out, but also some non-mission critical traffic that goes directly to the internet. We're not really interested in doing too much inspection of that in SSE, so we split that out. And then we tunnel the rest of the traffic into SSE itself. So SSE has a bunch of network and security components. Again, we don't have to worry about the infrastructure here. We just define the policy and that gets instantiated. But in terms of the traffic flow, depending on what application you're connecting to and how, TCP 80 and 443 traffic will then get punted to the secure web gateway. Then we can do some deeper inspection onto that HTTP traffic, apply some malware analysis. There's default integration with Cisco Talos Threat Intelligence. So that will allow us to do some proactive blocking at the web layer for URLs and domains. And then it'll connect out to that internet or SaaS application. There is something called reserved IP. So when you go out to the internet, generally your IP address gets natted because you can't, non-RFC 1918 addresses are the only ones accepted on the internet. So secure access does apply some NAT. They have this concept of reserved IP, which is the NAT IP you get is deterministic. And why is that important? Well, what we found during this transition is that a lot of our users or application owners have IP ACLs on their applications itself. So think of something like Amazon security groups. They will say only this range of IPs, in this case it's Cisco enterprise IPs, can talk to this application. So when we start cutting over users to SSE, they will now egress not out of our corporate NAT pools, but out of SSE. So we want to make sure that that IP address is deterministic and not shared with other tenants, so then we can confidently say to these app owners, you can permit this IP address space because it's dedicated to our tenant. The unfortunate thing is that's mainly for web traffic. So all other TCP and UDP traffic will go, for now, out a shared IP. but reserved IP for that specific traffic flow should be coming in Q4, so fairly soon. So yeah, we hope to benefit from that fairly soon. And then for private traffic, it'll go to something called a network tunnel group. And that's essentially how we manage access back to the on-prem data centers in our enterprise network. So we run IPsec. There's BGP peering within those IPsec tunnels back to our on-prem routers. So we have Catalyst 8K routers. They're running SD-WAN, so managed by vManage. So essentially all that config is just deployed via a template that has IPsec connectivity to secure access, and then BGP peering within that tunnel to exchange routes, and that's how we can make the enterprise talk to SSE and vice versa. One thing I want to double click on is this firewall piece I think is really important, and that's where we get a lot of the value, because while there's a lot of these security components within secure access, it's actually quite tightly integrated, which makes defining policy a lot easier and more deterministic. So if we look at how we deployed policy in the enterprise network back in the day, we had quite a few security enforcement points at specific elements in that journey of that connection flow. So we had the VPN that was doing the identity check. We went through that. That also applies in SGT. So if anyone's familiar with Cisco ISE, we have security group tags, which basically applies some metadata to the actual network traffic. We'll have some policy that permits or denies that connection. And then as we go through, we'll also have DNS policy. So part of the traffic flow is resolving DNS. So we'll have some DNS policy in place on both our on-prem DNS servers, but also Cisco Umbrella, which we utilize. It'll then go through a firewall, so we'll have some sort of layer 3, layer 4 ACL on that firewall to permit that flow. Then we'll have an IPS stitched in, so there's another policy for the IPS, which signatures it's got to inspect for. And then right at the network edge, we'll have one final ACL. So that's where we run things like BGP black hole and block some IP bogons, and kind of like broad strokes denies or permits for traffic destined to the internet. So if we look at that flow, there's quite a lot going on. We have 3 different teams, NetOps, SecOps, and InfoSec, that are managing over 6 enforcement points across 6 different management platforms for something as simple as allowing a user to access Office 365. So while it may seem simple, there's actually a lot going on when you kind of zoom out and look at it at a macro level of how we manage policy end-to-end in our network. Great thing about secure access is it puts that all together. So I can literally define an intent-based policy, which is permit a user to access Office 365, and then it'll go and figure out at a low level what that policy looks like across all these components. So while we're still 3 teams, we now just have 1 enforcement point and 1 management platform, which is quite effective for us and allows us to really focus on defining policy that helps our enterprise rather than how to engineer that policy within that network and make things connect. So if we look at globally what our architecture looks like, again, it might be a bit hard for you to see in the back, but essentially we're deployed in 11 locations worldwide. We have secure access in each of these POPs. And then they basically have on-prem connectivity, as I went through before, with our IPsec tunnels and BGP to our cloud ports, which house our on-prem applications. So a user from the bottom will connect to secure access via VPN. They'll go through some security enforcement. They'll then egress either to the internet if they're connecting to the internet, or they'll ride that IPsec tunnel back to the enterprise. And at this point, I think we have cut over the workforce to SSE, right? Great, yeah. I just got some friends in the crowd that have spearheaded this journey. So it's pretty cool to come to this moment. There's a lot of planning and effort that really went into it. And the outcome of that is we're now at a level where we can start decommissioning our on-prem VPN hubs and just rely solely on secure access for remote access. So that's VPN. Another component we looked at was the Duo Network Gateway. So if anyone's familiar with Duo, it's really more at the app layer, so gating access primarily to web applications. So if anyone's familiar with Beyond Corp, Google's paper on zero trust. It was written a while ago, and that's kind of one of the main things that proliferated zero trust throughout the industry. They essentially had a reverse proxy solution that allowed remote users to not even need to VPN to connect to on-prem apps, but they could just connect to them from the internet. So that reverse proxy was exposed, and then that applied a set of identity and posture checks to the device to only allow trusted users to connect to those on-prem applications. So Duo allows us to do a lot more specific policy. So when we think about VPN, you're authenticating once, but essentially you just get broad network access to whatever network segment VPN is permitted to. Duo is really looking at that per application level of access. So we get kind of closer to that principle of least privilege and micro-segmentation, where you have to authenticate and authorize to each specific application. It allows us to do things like validate the device trust, and also its health and compliance. And then we run things like SSO, so we have that consistent identity layer. Duo integrates via SAML for a lot of our on-prem applications. So that is kind of like the gatekeeper for our applications. That allows not needing to connect to VPN to connect to specific applications. So from an end user experience, they don't even have to bring up that dialog box and click connect. They can just open their web browser, connect to that internal app, making sure their device is trusted, and then just continue to work as usual. So in terms of, again, the control plane architecture, so we have kind of three main things. We have our managed device. We have our Duo network gateway, so that's positioned in the DMZ of our on-prem network. And then we have our corporate application that the DMZ is gating access to. So again, we have our MDM. Our device checks into MDM. We use Jamf and Intune. And then we also have the Duo Cloud that synchronizes with that MDM to get that device management status, and also the posture from the device itself. And then when we look at things like MFA, that's facilitated via the Duo Cloud as well. So we start off with our managed device, HTTP request to an on-prem application that gets routed through the Duo Network Gateway. Duo Network Gateway will then run those authentication and posture checks. And then if that's allowed, if it passes those checks, then we'll permit specific application to that application only. If you want to connect to another application, this process starts again. So really doing that continuous validation. So in terms of the data plane, what does the actual traffic flow look like? So everything starts with DNS. So we now have to expose a public DNS record of the domain of that application. So that will point to the DNG. So the DNG will attract the requests from that public DNS record, and then we'll route it to our on-prem network where that application lives. Because this lives in the DMZ, there's a firewall in between that gates access to the internal network segment. And when there's a firewall, there's an ACL. So you may start to realize some of the challenges with this architecture, not just managing security at the DNG, but also that firewall allowing those specific IPs and ports to talk to the internal network. So in terms of our deployment, we've got that deployed for all 170,000 endpoints across the enterprise. We have around 150 borderless applications. So when we say borderless, essentially you don't need a VPN to connect to these private applications. You just open your laptop, no matter what network you're connected from, it'll connect you through the DNG. We have around 420,000 user authentications per day across all our apps that are front-ended by Duo. And we have access across our entire device fleet. So Windows, Mac, Linux, iOS, and Android devices as well. Yeah?
Why didn't you opt here for clientless ETA secure access?
So clientless ETA was not a thing yet. So we started with DNG before secure access was fully deployed. We'll get to that. But yeah. Yeah.
Kind of tail off of that. Oh, sorry.
No, you go ahead.
So since you're using clientless or certificate authentication, why are you guys opting not to just do an always-on VPN and then not having to utilize the Duo gateway for access?
Yeah. So we don't always want VPN on because we kind of did this in parallel. So there's Duo work happening while we're also deploying VPN. But essentially, always-on VPN still only does those authentication checks at the time of connection. Duo does these checks at the application layer and sort of allows us to do that per app policy. So even if we had VPN, we'd still want to do these checks at the Duo level because it provides an additional level of control. And for a lot of those applications, it just mainly came down to user experience. It just made it easier to not have them fire up the VPN. But we will get to that when we get to secure access ZTA. That kind of gets us closer to that goal of, it is kind of like an always-on VPN, but we also get the benefits of doing those app layer checks. Yeah.
Yeah, I just wanted to ask, what does done look like for you with regard to your applications? It says you've got 150, and then also what happens for any applications that are not currently going through this process? How do you get to them today?
VPN for on-prem applications. We have a lot of cloud applications, so those don't need to go through the DNG. I think we have around 2,000 business applications, so there's quite a lot to get to. And as I go through in a bit, DNG is effective for web application, but we have a lot of non-web applications, and those rely on VPN access today. But that is what we're going to try and solve with secure access ZTA. It allows us to really get to that end state that you're talking about. So if we kind of zoom out on what I just talked about, we have VPN connectivity, and then we also have DNG connectivity for those roaming users. And there's still quite a challenge with this approach. So we have a corporate remote user. If they need to connect to on-prem apps, they go through a VPN. If they don't want to connect to VPN or they're connecting to an app that's already exposed by DNG, then they're routed through the DNG. But if they're sitting in the office where we have SD-WAN, that gets tunneled directly into the internal network. So we have kind of different approaches depending on where a user is sitting. And the problem with that is trying to get consistent security policy is really hard when you have different solutions that have different capabilities. The problem with the fragmented security approach and technology sprawl is it really creates those security gaps in posture. So what we really want to get to is a way to standardize all these access methods. So if we go through the challenges, I kind of alluded to this earlier on. So while VPN and DNG got us closer to that goal of zero trust architecture, there still is, quite a bit of challenges we need to solve. So first one, VPN still gives you full access to the internal network. So even though we're doing those auth checks at the time of connection, once you're in, you're in. And then I think our session timeout is around 7 days. So for those 7 days, you're viewed as trusted. The other thing, Geo Network Gateway, again, kind of alluded to this, is primarily for web applications, does now support SSH and RDP, but we have a lot of applications that aren't any of those protocols, so we can't put them behind the DNG. Also, we may have some web apps, but they're quite legacy apps, and if they can't integrate via SAML and SSO, then they can't be put behind the DNG. So that leaves us with quite a significant number of applications that we can't protect via this method. The other thing with Duo is susceptible to a lot of identity-based attacks. So while Duo does those trusted device checks, because it's browser-based authentication, it will rely on a session cookie, and we're seeing more and more of session theft attacks these days that threat actors are utilizing. So if they're able to insert themselves somewhere in that authentication flow, even though they're not on a trusted device, if they get a hold of that session cookie you're using for that connection, then they have full access to that application. So there is a bit of a security gap there that we want to solve, and we're actively seeing that being exploited in the wild. Different experiences, I alluded to this in the last slide, different connectivity methods, not just the different user experience, but also different security policies because we're running different tech stacks depending on how you connect. So that will leave excessive toil for IT and can frustrate users because we have multiple teams that are supporting multiple different use cases, and for an end user, it's not always apparent how they're connecting. They shouldn't really care, but if they raise a ticket to IT, they may get bounced around different teams to try and zero down and troubleshoot on that problem. So again, we want to try and standardize that level of connectivity as much as possible. So what's the solution? Cisco Secure Access, of course. So again, if we look at a high-level approach of how we generally approach application access in Cisco IT, there's kind of three main security checks that we do. The first one is user and device identity. Make sure the user is trusted, but also make sure that the device that they're on is trusted, aka actively managed by MDM, which is kind of the second check. Not only does it have to be managed, it needs to be checking in quite often. And then the third one is a lightweight posture check. So not only does it need to be managed by MDM, but we want to make sure that it's running a security agent. So in our case, it's Cisco Secure Endpoint, some sort of anti-malware endpoint service, but also be running a minimum OS layer, be patched, have disk encryption, all that good stuff. So these are the three things, and as you saw with our connectivity methods before, we have some level of these checks that are applied at different stages of the connection, either at the device layer or the network itself, or at the app layer. But for us, getting to that true zero trust philosophy is to apply all of these checks at smaller and smaller intervals. So we want to validate these things as much as possible, which will really get us to that continuous validation of identity and trust, and principle of least privilege. So there's a question at the back.
So with your posturing on that, what if they're not meeting? How do you repair them?
Yeah, so the question was, if they're not meeting that posture, how do you remediate them, or how do you get them access? So what happens if they don't pass those posture checks? Then they don't get access. So they will have access to certain IT tools that we've exposed that allows them to get within posture. So they will still have access via MDM. There will be a method to contact IT support and access the specific tools they need to remediate the device that doesn't need to go through all these checks. Yeah. Sure. So with VPN access, I've kind of broken down those three checks that we do and applied it at different layers as we go through a connectivity flow. So if we look at someone connecting to VPN and they're trying to connect to a private application, depending on the architecture of that application and where it's deployed in the network, there'll be different checks imposed at different layers. So at VPN, we do that certificate auth and we do that MDM check, and that is valid for the life of that connection. So for us, again, it's that session timeout of 7 days. They will get access to the entire network segment. And then from there, we have two options. Applications that are behind ITSSO. So we'll have some level of SSO authentication happening here. And then some of those applications will then have additional checks at the dual layer. Check if that device is managed. Check that lightweight posture. Some apps don't have those posture checks or those MDM checks. They're just behind SSO. Some apps have nothing. So they're not even behind SSO. Maybe they're not a web app. And then we just have some sort of unmanaged authentication to get to these private applications. It's not great, but it's a reality of a large enterprise environment. We have quite a sprawl of different applications. And depending on how you connect, you will get different security. So we get closer to what we want with the Geo Network Gateway, because Geo Network Gateway front ends any of those applications. So you resolve your public DNS query, that will point you to the DNG. DNG will do SSO authentication. So when you do SSO, you get that cookie, and that cookie is now only valid for that browser session, not just the whole network connection that we saw with VPN. But then after you've authenticated via SSO, we'll then do those MDM checks in the background, make sure you're managed, and make sure your device is within posture. And that is done per app. So the DNG will then use private DNS to route to the real FQDN of your application. So it allows us to have those 3 checks at some layer. But again, we mentioned not all applications can be put behind the DNG because it has to be a web app, it has to be modern, and be able to integrate with SAML. So while this is great, it gets us partly the way there. So secure access really is an evolution of this. So when we started looking at it, some folks were kind of viewing it as a replacement of the DNG. It's just another proxy that we put. Now it's just a cloud-managed proxy. But I think the fundamental difference is the DNG is a reverse proxy, and it operates more at the application layer. So it inserts itself into this SAML auth layer to proxy that connectivity to your application. Secure access, we put an agent on your device. Don't worry, it's still part of Cisco Secure Client. It's just the module called ZTA. And that will intercept network traffic to the application and operate more as a forward proxy. Now, what that means is your your application still runs its own SSO auth. Duo is not inserting itself, or secure access, is not inserting itself into that layer. It is just proxying that network socket. So this gives us a couple of cool capabilities, which I'll go through, but essentially, ZTA is not a one-to-one replacement of the DNG. It really is an evolution. So now if we look at this matrix of connectivity, you can enroll into Zero Trust Access. You can deploy a certificate on that device, and that'll automatically enroll you into the ZTA service in Secure Access. And then at the proxy layer itself, we're able to do all 3 of these checks per connection. So what per connection means is the way ZTA works is you'll open a connection to a private application. It'll work at the operating system layer to pull out that socket and redirect it to the proxy. So if I'm connecting to an application, let's just go with Google DNS 8.8.8.8, which has a web page. It will find that 8.8.8 TCP connection in my socket and redirect it. And then that socket is validated across all these checks. The other cool thing is you're placed in an isolated network with only that application able to be accessed. So because it's in front of the proxy, the real IP of that application is never exposed. And there's no ability to do any lateral movement once you're connected through this way, because every IP that you're connecting to goes through these checks. And then from there, we can do our normal SSO auth, and then if we want to, we can still apply these additional checks at the Duo application layer. But even for the applications that aren't fully integrated with Duo, we may not have those checks, but we still have them at this layer. So that means at some point through the connectivity flow, we are doing these 3 checks at decent intervals as well. The other cool thing is for even some web applications and non-web that may not have SSO, Secure Access allows us to initiate a step-up auth, so we can shoehorn in an SSO auth for those apps that don't support it, and really, add an additional layer of security, even though the app may not support it itself. So going back to that question of what's our end state, now we have a solution that can actually apply all the checks that we want, no matter the architecture of that application. So this can feasibly be implemented across all 2,000 business applications that we're running on-prem today.
But you're still doing SSO on top of applications?
Yeah. That's still to be debated. We still want that SSO layer because it allows us to do that user lifecycle management. Whereas right now we haven't got ZTA fully deployed across all applications, but once we have that, then maybe we can sort of look at compressing some of those. But yeah. So in terms of the architecture, whether you're a remote worker, even when you're in the VPN, or in the office, it doesn't matter. You're still connecting to ZTA the same way, because that agent will pull that socket out of the operating system and point it to the proxy, no matter what the underlying connection is. So now we sort of get to that state of no matter where you're sitting, you'll go through the same experience, which will mean for that private application, you go through the Zero Trust proxy, we'll apply those identity and posture checks. Secure access also chains in a firewall, so if we want to do some additional layer of inspection, so we want to still have an IPS in there or do some sort of malware scanning for that private application, we can still apply that. And then there's a few different ways we can connect to applications. The primary method that IT will use is IPsec back to the enterprise. But we also have the capability to run something called a resource connector. So resource connector is essentially a VM that you deploy in a data center or in a cloud environment that will initiate a reverse tunnel to secure access, and then you can route your traffic through that tunnel. Why is this interesting? Well, Cisco connects to a lot of third-party business networks that may have overlapping IP space. So it's not as straightforward to connect that overlapping IPs through this IPsec tunnel because we have an exchange of routes. Resource Connectors solves that problem for us. So we can connect to third-party private apps that are sitting in someone else's network without having to worry of how to do this whole network integration. We just give them a VM to deploy, and we'll automatically establish a tunnel with secure access and allow connectivity to those apps. Then the other thing that's coming in the future, this thing called hybrid ZTA. If you saw Universal ZTA mentioned at the keynote, or maybe you saw some other sessions, that's really what this is talking about, is for those private apps, do we necessarily want to hairpin them through the cloud just to come back to on-prem? Or can we connect directly to the on-prem firewall, which will still be running the same policy that's up here? So essentially, you still manage the policy via the secure access UI, but your data plane is now going directly to the enterprise instead of going up to the cloud and then back down. So that's something that we're evaluating for the future. So for us, the key differentiators are TPN-bound keys. So if you listen to what I mentioned before about the vulnerability of session keys and cookies that can get stolen from a browser, Secure Access ZTA does not utilize that method. It uses a hardware-bound key to authorize that session. What that means, so TPM is Trusted Platform Module on Windows. On Mac, it's Secure Enclave. And that key is literally on an isolated circuit on your laptop, and it can only be accessed via physical access to that laptop. There is no exchange of keys through a network connection. It authenticates through the cloud via this TPM-based keys, which essentially means a remote threat actor can't steal that session key. They need physical access to your device, and even getting physical access, it is quite tough to compromise this. So we'd say that the security of that is quite high and a differentiator for us that alleviates that vulnerability. The other cool thing is it's backwards compatible. So we talked about IT kind of wanting to approach this in a phased approach. When we did the DNG, because it operates at the app layer, once you front-end an app by the DNG, then anyone who wants to connect to that app has to go through the DNG. Because Secure Access operates more at the endpoint layer, we can say that only certain groups of users access this app through ZTA. So we can then start to onboard groups of users at a time to connect to these apps, and all the other users, they can still connect via the normal method, VPN or ZTA, VPN or DNG. So that allows us to sort of gradually expand the pool of which users connect to this app via ZTA instead of doing like a big bang approach where once you put an app behind ZTA, that's the only way you can connect to it. That's where we want to get to, but we want to be risk averse and kind of take a phased approach so we gain confidence with that solution. So that part is pretty cool. The other thing is if ZTA fails for whatever reason, it can fall back to VPN or DNG connectivity to that app, so you're not completely hosed. The other thing is it's very secure. So again, I sort of talked about each TCP and UDP socket goes through those authentication and authorization checks as opposed to just the whole browser session or the whole network session. And there's no exposure to public DNS. So with DNG, any sort of reverse proxy, you have to expose an A record and public DNS, and then that is very easy enumeration for an attacker. Because we use an agent that sits on the endpoint, that DNS record for the application is never exposed to the internet. And even the IP, like if I'm an end user, I will get a synthetic IP that I connect to on my laptop. So I don't need to know the IP. Obviously, I'll just type in the domain name in my browser. But if I try and resolve that domain, I'll get some fake IP. So for an attacker, there's no way they can use that to pivot inside an internal environment. So this might be hard to read for users in the back, but you'll have all these slides. You can go through the PDF and look at this in more detail, but I just sort of wanted to make it a bit more real. So in terms of creating the actual policy, we have our endpoint posture where we can define what minimum OS version endpoints need to run, how they need to be managed, what security agent they need to run. Then we can just define a simple policy that says this group of users need to access these trusted applications and allow that flow. And then we can define which applications actually go through that steering policy. So I think it is quite an intuitive UI and really allows us to get to that intent-based policy, which is my intent is for this group of users to access this application. I don't want to worry about all the low-level engineering of instantiating that policy on a network or a security device. The other cool thing is detailed app discovery. So once you get all your traffic going through SSE, there's some cool analytics you can do to look at your app utilization, and that was really helpful for our ZTA journey. We can identify which are the big apps that we want to migrate over to ZTA that will have the most effect. The other cool thing about visibility, well, the other challenge with visibility is traditionally in an enterprise network, we have a lot of feeds that are coming from a lot of different network devices. And then it's up to the security analyst to put all this data together and then run correlations across those. So in our enterprise environment, we have different systems that are sending data in different formats. And then it's up to the analyst to sort of make sense of all this data. Because we have all these functions integrated in secure access, we have a nice, clean way to look at this data where we can see the end-to-end flow of this user is accessing this application using this port and protocol. This is the exact URL of what they're accessing. Here is the posture of their device that they're accessing that from. What is the time of that connection? Everything in a nice UI. And we can also export all of that to Splunk in a consistent format. So going back to some of the value cases, and this kind of maps back to our main IT priorities, is we get better security because we uplift from VPN. We do that least privileged access per application. User experience seems to be a lot better because it's transparent to the endpoint. You just click connect and all those checks just run in the background. There's not much user intervention required. And then for IT operations, we no longer have to manage on-prem VMs and manage the lifecycle of that. It is just a cloud service. We just need to get the agent deployed on endpoints via MDM, and then they just connect to the cloud. So the North Star vision is we start with what we have on the left, which is Geo Network Gateway combined with the VPN. Most of our users still need the VPN for some level of application access because not everything is behind the DNG. So we still have some matrix of connectivity across these two. But the main point is at least shift the VPN to the cloud, start to make use of that centralized policy enforcement model, then use that enhanced telemetry that we get from moving all that traffic to the cloud to then identify which applications will be most effective to move to ZTA. And then we want to migrate all the applications we have behind the DNG to use this new method of ZTA through secure access, which we think is a much more robust and flexible connectivity model. And then the last step is if we can get all those apps behind ZTA, and that's kind of close to that always-on VPN because it's just continually running, we can start to limit access from the VPN. So the VPN shouldn't allow you to access everything in the internal network because if you can access everything you need through ZTA, then the VPN doesn't need to be as open. And we can start leaving the VPN only open to certain network segments for very specific applications that for some reason we don't want to or we can't put behind ZTA. So that's kind of the end goal. So there's a lot. Some of the lessons learned through this journey, number one, I think for sure, is as engineers, we kind of tend to think quite tactically. I think it's quite important to develop a strategic vision, get buy-in to that North Star vision of the principles of what we want to achieve. Put away all your expectations of how stuff runs today. Just think about what's the end state. If I could start from scratch, what would be the ideal solution? get agreement on that and then work towards that. And then executive sponsorship is super important, at least for us in a large enterprise. It's kind of hard to drive solutions bottom up. If you can get agreement from the top and then drive that top down, it is a lot easier to get to that North Star vision. And generally, if you can articulate that North Star vision well, it's much easier to get that exec buy-in. The other thing is we worked across quite a lot of different teams. So all the things that I talked about in this presentation, we covered stuff that's running on the endpoint, the applications themselves, and also in the network. So making that successful required a lot of agreement across a lot of different teams. The way we approached this is to create a virtual team. So some of the leads from each of these, we met quite regularly and make sure we were aligned on those strategic priorities, that North Star vision, to then sort of disseminate the work that actually ended up, in each of these teams. And the other thing is balancing speed versus risk. We want to get to that North Star value case. We want to get there fast, but obviously as a large enterprise, you have to take into account going fast can possibly mean more problems and more issues you run into, which ultimately makes you slow in the long run. So there is a balance of both that you kind of want to achieve. And for us, that looked like, that phased approach of, we're still going to be careful about this, but we're going to be aggressive. So we're going to give users a nudge and make that nudge more aggressive so we can really have time to understand and evaluate the risks, but also move at a pace where we start to get that business value as quickly as possible to get that momentum to reach that North Star vision. So I think we're just about at the end of time. Appreciate you all coming along. Make sure to complete your session evaluations. Tell me if that was great. Tell me if that sucked. It's all good feedback. Really appreciate that, and will also help me make this session better for you guys. So with that, we're kind of near the end of the conference anyway, so some of these might not be as relevant, but please come and see me or contact on WebEx if you want to go through anything in more detail. Thank you, guys.